Hello, my name is Mark Fennell, and today I'm going to talk to you about electrical current as created in batteries and in power lines. Now today's instruction is going to be a very high-level overview. Why? Because I have made significant discoveries in several areas. Therefore, subsequent videos I will have detailed illustrations, detailed models, showing, explaining processes in greater detail. I want you to know that there are many types of electrical current. Current can be created in many ways, and the actual process of electrical current can be done in various ways. The two most common types of current are found in batteries and in power lines. Now, I've done some research, and I've discovered I've discovered a more detailed understanding of how current exists in a battery. I've also discovered a deeper understanding of how electrical current exists in a power line. So those are two new discoveries that I have made. In addition to the fact that I've discovered that these two processes are completely different. So today I'm going to give you a high-level overview of both processes. Electrical current in a battery. How is this created? We have two metals, an anode and a cathode. The anode and cathode are only defined relative to each other. Why is that? We're talking about the pull strength of the nucleus. It's like comparing Jupiter versus Pluto. If you stand next to Jupiter, you're going to be sucked in right away. Stand next to Pluto, not so much. Why is that? Because of the different strengths and gravitational pull. The same thing with our two different materials. The nuclei in one material has a strong pull, the nuclei in the other material has a weak pull. So what do? We have a process which creates free electrons. The process is well known, isn't important right now. But once we create free electrons, which way are they going to go? The same thing if you stand next to Jupiter or versus next to Pluto. You're going to zip over to Jupiter. Why? Because of the stronger pull. The same thing with our two materials. Create the free electrons, they have a choice in which material to go to. They're going to go to the material which has the stronger pull of the nuclei. Thus, the free electrons are created, they go somewhere, they're going to zip through the wires all the way over to the nuclei with the strongest pull. That is what creates the electrical current in a battery. Now the power line is completely different. And most of my research and most of my studies are done with power lines. In a power line, what we have is a generator. The generator is a magnet. The magnet creates a magnetic field. This magnetic field is a push. We have a magnetic field, essentially an external push, pushes the electron. This electron pushes the next electron, which pushes the next electron, which pushes the next electron. What we have here is a series of consecutive electrons bumping down the wire. Then the magnetic field changes direction, and it pulls the electrons. And again, they go bumping, reverse order. So again, how is electrical current created in a power line? We have a magnet. The magnet has a field. The field creates an external force. That force is applied to the electrons, which can come down the line. Completely different process. So again, this is a high-level overview. I'll be providing illustrations later on. In a battery, the current is created because we do free electrons. They're pulled by the nuclei that's stronger. In a power line, electrons remain on the wire, but we're pushing them along, and the push is created by a magnetic field. And that is my discussion of power lines and batteries and electrical current. That is my today's video. Thank you.